Good afternoon. It's my pleasure to have an opportunity to introduce some of my study of medical or health information by image processing. So this is a session of e-commerce and digital marketing. So I would like to talk about how we can make use of digital data, especially in the area of health or medical information. So first of all, I will talk about personal health record front-end system for easy data migration from paper-based information. So the motivation of this work is something like this. So this is a little bit old data, statistics, but this list shows that top 10 countries of life expectancy and births. And as you can see here, Japan is one of the countries where the life expectancy is higher than other countries. So here arises an issue that because of this situation, now the Japanese government have a problem from economic point of view, because the economic liability for sustaining social insurance system is not negligible. So the cost for maintaining social insurance system is becoming higher and higher in recent years. And there is an increased need of self-management of personal health. So the idea is that more Japanese people are recently relying on social insurance system to go to a hospital, even for not serious diseases. Just to have a slight cold, all the people will tend to go to the hospital, and that is one reason why the cost of sustaining social insurance system is increasing. So most of the older people are going to hospital as going to the school for young people, and so therefore, Japanese government is trying to minimize the cost for a social insurance system, especially for medical area. So that's why we are recently developing electronic health record or personal health record system based on information communication technology. Okay. So as you see that Japan is one of the very developed country, and the healthcare system is also well developed. And this is a snapshot of the example of annual health check report. So in my case, JAISE is taking care of the employees' health. So therefore, we once a year we are taking a health check, measuring various kinds of indices, like you see height, weight, BMI, and army test, and circulatory organ test, and so on. So the items to be checked is more than 40. And this is very good opportunity for us to recognize the condition of our health. But this record is distributed in the form of paper, printed form of paper. That is printed on the paper and distributed to each of the employees. So this is a problem because just after taking a look at the report, we will forget about it and throw it away. And we have less chances to take track of our health record to see our health condition is going better or not. So one issue is how we can migrate such information to, for example, smartphone or laptop PC to take care of our health by ourselves. So one possible way is to prepare such a web-based system to enter such personal health information on the web one by one by keyboard. But that is time-consuming, and it takes time, and it's not so much interest for each user. So what we think about this is how we can migrate such printed information of personal health record into mobile devices easily. So how we can do like that? There are devices such as image scanner, which has the ability to recognize character, that is to transfer image information into textual information. But here there is an issue that how we can recognize, how the optical character recognition software can recognize this kind of table by associating the name of attribute and values. So therefore, image scanner with optical character recognition is not a good solution for data migration. So what we saw, and another issue is that, as you can see here, if we apply optical character recognition for pictures that is taken by handheld mobile devices, here appears a certain number of errors, as you can see in red letters over here. See, these red letters correspond to errors in optical character recognition. So therefore, easy application of optical character recognition will result so many errors to be corrected by human work. So this is another issue, explaining that the simple application of ready-made optical character recognition will not be a solution. So therefore, we have developed a system that will run on mobile devices such as iPad, like this. This is the initial screen of the prototype system. And I'm sorry, this is a little bit dark, but here is a place to select the investigation, the name of the health check organization. And after that, here appears a screen, and so that a user can take a photo of this report of health check. And here appears the screen with the camera screen, so that he or she can take a look at this report on this tablet. And it's a little bit difficult to see, but here appears white rectangles over here, so that it tells the user to know which part of the table he or she should take. And this is a screen, so that it tells the user to show where to shoot on this table. And by showing this kind of intuitive interface to the user, so user is easy to know which part of the table should take to migrate the data. And this is another snapshot showing the result of character recognition. This part corresponds to a picture that he or she just input for this health check report. And this upper half of this part corresponds to the result of recognition. And by doing this, it is very easy to confirm the picture that is taken by the user, to confirm if the result of character recognition is correct or not. And so this screen is synchronizedly, this part and this part are scrolled by a hand gesture in synchronized way, so that the user can confirm the correspondence easily. Okay, now let me move on to the second topic on detection and classification of parasitic worm from microscopic images. So this is a collaborative study with Kanagawa University in Japan. So the matter is something like this. Nowadays, Japan is in Japan, there are much less cases of diseases that is caused by the parasitic worm. So therefore, there are much less chances for a doctor to see this kind of parasitic worm that is observed as in a microscopic image. So the matter is how we can help the doctors to find such a plastic worm, that will be a that will be the reason for diseases. However, the difficulty of this topic is something like this. So this is a plastic worm, but this is not a plastic worm, but visually this is similar to this. So the matter is how we can separate plastic worm from outliers, something like this. The method which we can do is to try to learn visual features from positive examples as well as negative examples like this. And how we can do by image processing is something like this. So first we are doing is to decompose the image of this kind of plastic worm into pieces, something like this, and classifying similar visual pieces of information together and accumulate how many visual parts appear in this image. And after that, we will figure out the histogram of the visual parts to see the characteristic of the plastic worm, to see and also it is possible to recognize and identify the species of the plastic worm by taking the similarity of the histogram of visual information. And this is an intermediate result of detecting the plastic worm. But I'm sorry, this is a little bit difficult to see, but over here you can see green lines and red lines that is scattered all over the image on the right. And that is the failure cases of detecting plastic worm. But if you can see the picture on the left, there is a red lines are converged into the area of plastic worm over here. And this shows that visual matching of the parts of the plastic worm is succeeded to detect this worm. By doing this, it is possible to detect plastic worm from the image and identify what kind of species of the plastic worm is found from microscopic image. Okay, now time is limited, so now let me move on to the next topic on detection and classification of AML. So, as you know, acute myeloid leukemia is one of the serious diseases for human, and AML, that is the abbreviation of acute myeloid leukemia, is simply speaking, a cancer of white blood cell. And detection of the symptom of acute myeloid leukemia cell is very important from the point of view of minimizing the damage of the human. So therefore, it will be very nice if image processing is able to detect and classify AML cell automatically, not taking the effort of doctors. So the story is something like this. So we can offer a blood test to take photos of white blood cell and try to automatically classify and detect AML cell if there is. And the matter is something like this. There are 4 kinds of stages with regard to acute myeloid leukemia. So the matter is how we can detect and classify such white blood cell automatically by the aid of image processing. So the first thing we should do is to detect white blood cell like this from the blood image. So what we do is to convert color representation from RGB to CMY color space to emphasize the difference of the color between red blood cell and white blood cell. And this is the result of taking white component to emphasize the existence of white blood cell. And after that, we can take a gradient magnitude. Well, that is a little bit complicated story, but simply speaking, it is to try to test the intensity of the luminance to detect the area of white blood cell. And so as you can see here, even if we try to detect white blood cell, this part it seems to be missing. But this is also a part of white blood cell. So therefore, we will merge two results of strong region detection from structural method, and also we merge with the result of weak moves from gradient magnitude to finally detect this complete shape of white blood cell. Of detecting white blood cell, as that is segmented with green lines. And after that, classifying the AML cell into the category of M 1, 2, 3, and 5, we will take the features of white blood cell by taking the color features, histogram features, and textural features, and to create 33 dimensions of feature vector to classify each white blood cell by applying support vector machine. But let me omit the detail of support vector machine. But this is an algorithm to classify a AML cell into 4 classes, and this is a result of detection of AML cell. The performance is over 90%, and the accuracy of classification is also we achieve more than 90% like this. Okay, now let me move on to the last topic of automatic segmentation of jaw from panoramic dental X-ray images from using gradient probes next. So this is a collaborative research with Malaysian University, but well, this is an example of panoramic X-ray image of jaw. What we need this kind of image is something like this. So in some cases, because of for example, murder or something like that, I found a person with very little evidence to identify who he is or who she is. So in such cases, it is very important to detect the alignment of piece as an evidence to identify a person. So in such case, the matter is how we can have this kind of issue by the aid of image processing. So what we want to do first is to detect this area of this oval area that includes this. And because if we try to detect piece from this original image without segmentation, the accuracy of detecting piece will be worse because such surrounding area of bone will be detected as a failure. So therefore, to improve the accuracy of detecting piece, we would like to do is to detect this area, this oval area, including piece. So what we do is to apply K-means clustering and detecting point around the jaw detection, and after that we will apply gradient vector for snakes and to finalize the position of the area, including piece. Well, time is limited, so let me briefly explain how we do this. So first of all, what we do is to detect the upper and lower boundary of the area, including piece, like this, by changing the resolution of the original image. And after that, we will finalize the border, including the area of piece, like this. And this will be the initial condition for applying GBF snake. GBF snake is an algorithm to detect the boundary of the area which includes a specific object in the image. But simple application of the algorithm of snake will result failure, something like this. So these cases are examples of failure cases that is failed to include all the area of these like this. But applying the initial points so that it includes the jaw, the GBF snake succeeds to include all the area in all the pieces, all the teeth in the overall area like this. And after applying such processing, we are going to detect each piece of teeth to evaluate the spatial feature of the alignment of the teeth to identify each person. So the summary of my talk is this. So now we are in the area, in the age of computer science, and the computer is distributed in our life. However, there are a lot of paper distributed information, and that is not yet migrated